Welcome to the TCC Learning Commons. My name is Sam, and I'm doing a Chemistry 1045 workshop on chemical bonding. So, there's three types of intermolecular forces in Chemistry 1045, which y'all will get into later in the chemical bonding chapter. What I'm going to deal with mostly now is what's called the octet rule. So, on the periodic table, you have a periodic trend. Let's pretend this is a periodic table. You have a periodic trend called electrochemistry or electronegativity. And it increases the more right you go and the more up you go. Basically, every single element on the periodic table wants to have 8 electrons, but the more right and the more up it is, the more it wants those 8 electrons. So the two examples are fluorine and francium. Fluorine really wants electrons, francium just doesn't really care because its electronegativity is really low. So whenever we're dealing with chemical bonding, we draw what are called Lewis dot structures. So for example, let's do let me make it bigger. Let's do SO4 2 minus. So the first step of Lewis dot structures is you have to figure out what the central atom is. Since there's 4 oxygens and 1 sulfur, sulfur has to be the central atom. So we're going to draw sulfur in the middle, and we're going to surround it by 4 oxygens. And then the second step is you have to draw a bond from the central atom to every other atom. At least a single bond. Because this way now they're bonded together. Now it's sulfate. The last step is we have to, any extra valence electrons we have, we need to put around every element that doesn't meet its octet rule. So if we look at sulfur, right now sulfur has 4 bonds, and each bond represents a sharing of a pair of electrons. So that means sulfur essentially has 8 electrons, 8 valence electrons, which means sulfur is good. So we're only going to put valence electrons around the oxygens. And if we were to count up the total number of valence electrons, if we add up, I think each oxygen is 6 electrons. And then I'm not sure how many sulfur is. Let me check. And sulfur is 6 electrons. So this would give us 24. And if we add up, let's count the number of pairs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and then the last step is to calculate the formal charge. So sulfur normally has 6 valence electrons. If we look at the periodic table, it's in group 6A. So to calculate the formal charge, you just do the number of valence electrons minus the number of bonding pairs around it. So it has 4 bonding pairs, which means it's a +2 charge. So we know sulfur is a +2. We know each oxygen is a minus. So the formal charge on sulfate is, as we know from polyatomic ions, -2. And that's the basics. I'm going to do one more that deals with double bonds, just so that you have an example of each rule. So the classic example of Lewis dot structure with double bonding is CO2. Everyone knows what CO2 is. CO2, carbon is going to be the central atom because there's 1 carbon and there's 2 oxygens. So we're going to draw a carbon and 2 oxygens. If we total up the number of valence electrons, we have 12 because each oxygen is 6 plus 4, so we have 16 valence electrons to work with. So if we put a single bond on carbon, that's 4 electrons used, so that means we have 12 left to distribute. If we put those 12 around the oxygens, like this, 6 electrons on each oxygen. Now the oxygens have their octet, if we count, right? 2, 4, 6, 8. The oxygens are happy. They meet their octet. but the carbon only has 4 valence electrons, which it starts off with, so it would have no reason to even bond like this. So this is one. So what we're going to do is we're going to erase these electrons on oxygen. And now, since this carbon and this oxygen both want an extra pair, they're going to form one more bond. Same with this one. They both want an extra pair, so they're going to form a double bond. And now if we count, carbon has 4 pairs, oxygen has 4 pairs, and oxygen has 4 pairs. Other than, I think the one weird example is boron. Boron makes an expanded octet, but that's a whole nother. This is basically the gist of Lewis dot structures and chemical bonding. Does anyone else have any questions? Nope? Okay. Well, we'll have another workshop next week on thermochemistry.